This is Algebra 2B, Trigonometry Lesson 7, Sunrise, Sunset Project. So I'm going to be going over and doing most of the project with you, but leaving some things for you to do on your own. It starts off on December 21st, 2021 in Anchorage, Alaska. The sun rose at 10:14 a.m. and set at 3:41 p.m., giving 5 hours and 27 minutes of daylight. On the same day in San Juan, Puerto Rico, there were 11 hours and 1 minute of daylight. In this project, you will use Google Sheets to investigate the amount of daylight in a location of your choice and then create a sinusoidal model for the data that you collect. To start, please head over to the Google Classroom and find the project. It should say Sunrise Sunset Project, and we have a link here that we can use, and we also have the Google Sheet attached here. So go ahead and click on the Google Sheet. It should bring you to one all on your own, and go ahead and click on the link to get you your data. Okay, so I have the sheet open, I have the website with the data. We're going to select a city, set the month to January, select day length, select make calendar. So I'm going to select I'm going to go Manila. My mom is from the Philippines. Manila is the capital of the Philippines. I'm going to go January. I make sure day length is selected, and then I can make calendar. So now this has the sunrise, sunset, and day length of each day of January in the city of Manila. At the bottom, there's also some quick links that'll bring you to the next month and the next month and the next month that we're going to be using. Okay, so once we have the calendar on the sheet, we're going to input day length data for the 1st and 15th day of each month for 1 year. Okay, I'm going to try to split screen this. I think it's going to make it a little easier for me. If I can have this data here, and if I can have my calendar here. Okay, so on January 1st, to type this, you need to type equals, remember our formulas, the number of hours plus the number of minutes divided by 60, and it's going to convert your minutes into a decimal of hours. So like, for example, 30 minutes, we know that's a half hour, so it'll make it a 0.5 instead of 30. So what I mean is here on January 1st, I had 11 hours and 17 minutes of daylight. So I'm going to type equals 11 hours plus 17 minutes. Because there's 60 minutes in an hour, I'm going to use that fraction to convert it to a decimal of hours rather than a number of minutes. And we hit enter, so 11 hours and 17 minutes is the same as 11.28 hours. Next, I'm going to go to January 15 and do the same thing. January 15, I had 11 hours and 21 minutes, so equals 11 and 21 over 60. Scrolling down, I can use the link to jump me to February. And on February 1st, there were 11 hours and 30 minutes. So equals 11 plus 30 over 60. And on February 15th, it looks like 11 hours and 40 minutes. Equals 11 plus 40 over 60. I'm going to pause the video so that I can finish typing these all in. You please go ahead and do the same, and we'll meet you back in just a sec. Okay, so I have my daylight hours for 1 year in Manila. I'm going to go ahead and add that here too. Manila, Philippines. Okay, so now that I have that data there, I don't really need this calendar anymore. I'm going to make him large again so that hopefully we can see that better. But all these numbers that I typed in here for data, notice that it got graphed automatically over here, okay? And it's a pretty shallow curve. That's because the city I chose is pretty close to the equator. But we have the lowest number of hours up to the max and then back down again, and that curve is going to repeat every single year. So my goal then is to put some different values in here so that I can see an equation and hopefully come up with that. I'm going to start by just putting in some random numbers to kind of see what happens. So these numbers are being generated automatically based on the equation, and I scroll down more, you can see that equation based on the numbers. So right now I'm graphing y equals the cosine of x plus 1 plus 1, right? And it's giving me 1 year, that's my period. Here it would be like 2 years, right? 2. And if I change that to 3, you can see how I have 3 cycles now. Our amplitude, remember, changed how tall our graph got. So I can make this like a 2, and it's getting taller, or a 3, and it's getting taller. It's kind of going off the screen. So maybe I'm going to play with my vertical shift. That'll slide it up. Maybe if I slide it up to 5, you can really see those curves taking shape. So the goal is to think about what each of these numbers mean, and then try to get a graph to match pretty good. So I feel like my horizontal center line is at about 12. So I'm going to go 12. See how it slid it up to match the blues a little better? I already said I'm only graphing 1 year, so I probably want my period number to be 1 year. And you can kind of see them upside down. Well, maybe I can put a negative in here to flip it over. And that's how tall it is. Remember, it's half the overall height. So right now I am stretching it way too much, so maybe only -2, maybe only -1. You can also put some decimal values in there if you want, and just recognize that each time I change these values, it's automatically putting into my equation over here. So you choose your city, input your data, generate an equation, try to get as close as you can get. Once you have that done, there are some reflection questions underneath. If you have any questions, please let me know. I also want to show you one more thing, and that is this one here. I also did Anchorage, Alaska, just so I can kind of do one more where we're looking at changing the numbers. And the reason I wanted to do this one is because if you look at the Philippines, it's a pretty flat curve, again, because it's really close to the equator. Whereas Anchorage, being closer to a pole, has a lot steeper of a curve. It's still centered pretty close to 12, but my amplitude is going to be a lot bigger to make that happen. So just so you can kind of see some variety here. Again, play with the different numbers based on your city, get an equation, and answer the questions below. Please let me know if you have any questions.